Hello and Assalamualaikum. These are members of our organisation led by ASYIKIN binti Muhammad AZAHARI as Managing Director, Siti HAMIZAH binti Ahmad as Project Manager, Muhammad Falah bin Ahmad Kamil as Joint Technical Engineer, Elijah GUPIE Anak 1 as Civil Engineer, Vincentio Seng as Civil Engineer and Muhammad SYAHRIN bin AZHAR as Structural Engineer. Next, about the company profile. Our company name is Solid Foundations Sdn Bhd. It's a registered engineering consultancy firm in Malaysia. We are recognized by the Board of Engineer Malaysia (BEM) for comprehensive engineering service. We also provide a wide range of expertise in geotechnical and foundation design, civil and structural engineering, water supply and dams engineering, marine and port engineering, coastal and hydraulic study, environmental monitoring plan, and project management. We also focus on practical and value money for service while accommodating clients' changing needs and budgeting limits. Our team consists of highly skilled and experienced geotechnical and civil engineers. Next, for the project background, the project objective is to design and construct a durable and structurally sound foundation for a double-story bungalow. The site analysis, which is comprehensive assessment of soil composition, layer capacity and potential construction challenge of bricks. The location is Lot 2310, Jalan Sudara Kemengansat, Taman Sudara 81200, Johor Bahru, Johor Darul Ta'zim, Malaysia. The consultation made is type of foundation, depth and reinforcement technique carefully planned, including load transfer from upper floor to the foundations.
Assalamualaikum and hi, I'm Muhammad SYAHRIN bin AZAHAR and I will be presenting about our literature review, which is first the site investigation. It is an important part of the foundation project which gives significant knowledge about the geotechnical characteristic and ground condition of the site. It is a methodical and thorough investigation of the location to acquire the information required for planning and building a solid and secure base. And for the objective, it is essentially provide information for the site selection, foundation and earthwork design, temporary work design, the effects of the proposed project on its environment, investigation of existing construction, the design of remedial works, and finally for safety checks. There is basically 4 components or steps in site investigation which is involved with 4 phases, which is phase 1 is literature review, next is phase 2 is reconnaissance subsurface exploration, and for the phase 3 is laboratory testing and reports, and finally phase 4 is detailed site investigation. And the importance of a site investigation when starting a new construction is basically to minimize the damages, save on costs, help determine the construction materials, and to increase the safety of the projects. Next, we jump to borehole data. The term of borehole data refers to information gathered during the drilling and sampling of a borehole or well, also known as borehole data or geotechnical logs. Borehole data normally consists of a variety of measurements and observation depending on the goal of the drilling and the necessary information. And finally, our project for the study, we selected borehole 1 for borehole data analysis. And from the figure we can see is the example of borehole data that we use. And from this borehole data, we managed to identify type of soil and all the data and information we managed to collect to make the calculation.
Hi, my name is Vincentio. Now I will explain about our group in analysis of the structure. For the first 3, we given lot in our analysis is P1, C42 is 156.3, and then P1 also in the other position, and P2, P3 and P4 is the maximum log, 1492.3 cm. Okay, now we go to the methodology on our project. So for the first is we calculate the bearing capacity and settlement, which is we use the MOHD method in clay, which is the pi is 0, the assume is 0, the degree. And then we calculate the QS, which is the lambda method because of clay soil. And then we calculate the ultimate Q, which is the ultimate load. Our group assume as group out. And last one is we check the settlement by use the MOHD method. So lastly, the settlement under 65 mm is okay because it is clay soil. So that is 2 only it's not okay, which is the P3 only that's not okay. The other is pass for the settlement.
Hello, my name is ASYIKIN binti Muhammad AZHARI and I will explain about the pile calculation. Okay, so the group select pile P1 for the presentation purpose, which is this pile carried load for 156.3 kilonewton. And as for the QP calculation, we use MOHD methods and got the value for QP is 28125 kilonewton. Okay, so as per the QS calculation, the group select the lambda method to get the value for QS, which is 3139.2 kilonewton. As per the QU, which is QP plus QS divided by FOS, which is 10421.4 kilonewton, is more than the previous actual load on pile 156.3 kilonewton. So the ultimate barrier capacity on pile is acceptable. Next, we move to the settlement for pile P1, which is the clay layer, is to be assumed as normally consolidated clay. The pile used in this study act as group, and the value for QGU is 20009 kilonewton. As for the settlement, this group analyzed by 3 layers, which is the first layer after the stress distribution, give the value for 43.4 mm. As for the settlement for second layer, which is 3.8 mm, and as for the third layer, which is 1.2 mm. So the total up for all 3 layers for the settlement value is 48.4 mm. The settlement value for P1 is acceptable because it's less than maximum settlement value, which is 65 mm. So the settlement from this suggests that pile P1 is okay.
For discussions and recommendations, is explained about 6 aspects, which is the first one is site evaluations. We use borehole log data indicates clay soil compositions, and the safety factor value is 3, which is considered for the structure strength. And the second one is project scope, which is explained about the project involved collecting and analyzing borehole data and conducting foundation design and performing safety inspection. The knowledge and experience gain will be available for future projects. And for the method used, we use Meyerhoff method and lambda method for determine bearing load capacity, and for determine settlement we use Meyerhoff method. For the pile foundation, we are chosen to support the load from each column. Okay, for the evaluations of pile foundation, we have 6 type of pile foundation, which is P1, P2, P3, and P4. We are assess, determine design load, and suggesting foundation design size. And for the settlement check, the maximum allowable settling in clay swale is 65 millimeters, and settlement checks are conducted for all purpose pile foundation, revealing that pile P3, which is C9 and C16, exceeded the allowable settling limit. For the conclusions for discussion is a deep foundation system, specifically pile foundation, is recommended for load support. Deep foundation transfer weight to stable soil or rock layer, ensuring that sufficiently and safety of the structure through the engineering analysis. Okay, for the recommendations, which they are for the pile P3 C916 design, which is this design did not meet the maximum allowable settling limit. Then we recommend revising this design, possibly by adjusting pile size or exploring alternative foundation system. For additional stress investigations, conduct further soil investigation to gather accurate information and refine the design, select appropriate sub-foundation types and size. For the quality control and construction, we need to implement quality control method during pile installation, regular inspection to ensure compliance with design parameter, and work with experienced technical expert for insight and guidance. Okay, for the last one for recommendation is monitoring and maintenance. Regular monitoring and maintenance of the deep foundation system detects and address problems to ensure long-term stability. Okay, that's all for discussions and recommendation for these pile foundation designs.
Assalamualaikum and hi, my name is HAMIZAH. I will present our conclusions. For conclusion, we get from data based on project background and also calculations. So a solid foundation for double-story bungalow was successfully designed and constructed following calculation and adherence to the standards. The chosen pile foundations consisting of 12-meter concrete piles, accommodation a load range of 156.3 kN to 1492.3 kN. Calculation confirmed that the ultimate bearing capacity of all piles meet the required standard, which is we use 2 methods, which is Meyerhoff methods and also a lambda method. For the settlement calculation, we indicate that pi 1, pi 2, and pi 4 did not exceed the maximum allowable settlement, which is okay. While for pi 3 does not exceed the standards, which is it's a low standard, which is not okay. So we need to redesign the file. That's all for me. Thank you.